Hello, 6th graders. Welcome to Big Ideas Math, Contract Math, Section 7.5, 2014 edition, Scale Drawings Lesson. Pause while you write Section 7.5, 2014 edition lesson in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is use a scale drawing to find a missing measure. Today we'll be starting on page 300, example 1, finding an actual distance. What is the actual distance between Cadillac and Detroit? So we need to first find those on the map. Here's Cadillac and here's Detroit. Step 1, use a centimeter ruler to find the distance on the map between Cadillac and Detroit. So you would use a centimeter ruler, and we're using centimeters because we can see that our map scale is in centimeters. The map distance is about 3.5 centimeters, and we use the scale to write and solve a proportion. So 1 centimeter equals 50 miles, and 3.5 centimeters equals d miles. So we write the proportion like we have here, and then we solve it. We use the cross products property, and we cross multiply. So d equals 50 times 3.5. So d equals 175. So the distance between Cadillac and Detroit is about 175 miles. We're going to move on to page 301, example 2, finding a distance in a model. The liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of Earth has a scale of 1 inch to 500 kilometers. How thick is the liquid outer core of the model? So here is our proportion. 1 inch to 500 kilometers equals x inches to 2,300 kilometers. So we have the model thickness over the actual thickness on both sides. So we use, again, the multiplication property of equality, and we cross multiply. So when we work all of that out and solve for x, we end up with x equal to 4.6. So the liquid outer core of the model is 4.6 inches thick. A scale can be written without units when the units are the same. A scale without units is called a scale factor. You should already have that in your notes from the last lesson. So in example 3, we are finding a scale factor. A scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What is the scale of the model? So we take the model height and put it over the actual height, and that's 10 inches over 100 feet. And then we get it so it has 1 on the top, so we basically simplify it. So it's 1 inch to 10 feet. So the scale is 1 inch to 10 feet. What is the scale factor of the model? Write the scale with the same units. Use the fact that 1 foot equals 12 inches, so the scale factor equals 1 inch over 10 feet, and then we cross out inches and substitute in 120 inches for 10 feet. And so our scale factor is 1 to 120. On page 302, we're going to be doing example 4, finding an actual perimeter and area. The scale drawing of a computer chip helps you see the individual components on the chip. Letter A, find the perimeter and area of the computer chip in the scale drawing. When measured using a centimeter ruler, the scale drawing of the computer chip has a side length of 4 centimeters. So the perimeter of the computer chip in the scale drawing is 4 times 4, which is 16 centimeters because it's a square. And the area is 4 squared, which equals 16 square centimeters. Now, for letter B, we're going to find the actual perimeter and the area of the computer chip. So the drawing distance is 4 centimeters, and the actual distance is x millimeters. So we have a scale of 1 centimeter to 2 millimeters. So again, we use our cross products property, and we multiply. So 2 times 4 is 8, so S equals 8. So the side length of the actual computer chip is 8 millimeters. So the actual perimeter of the computer chip is 4 times 8, which is 32 millimeters, and the actual area is 8 squared, which is 64 square millimeters. What you cannot do here is take the 16 square millimeters and multiply it by 2 to get your millimeters, because 16 times 2 obviously is not 64 square millimeters. So you have to get your millimeters, your side length in millimeters, and then square it. Letter C, we're going to compare the ratios, the drawing perimeter over the actual perimeter and the drawing area over the actual area to the scale factor. So we use the fact that 1 centimeter equals 10 millimeters, and so we get a scale factor by doing 1 centimeter is equal, 1 centimeter over 2 centimeters is equal to 10 millimeters over 2 millimeters. So we're just substituting in millimeters for centimeters. And then we simplify, and we have a scale factor of 5 to 1. And then we put our drawing perimeter over our actual perimeter, and our drawing perimeter was 16 centimeters. Our actual perimeter is 32 millimeters. So when we simplify, that comes out to 1 centimeter over 2 millimeters, which again simplifies down to a scale factor of 5 to 1. And then when we do the drawing area over the actual area, we have 16 square centimeters over 64 square millimeters. And when we simplify that, it's 1 centimeter squared over 4 millimeters squared, and 1 centimeter over 2 millimeters, and the whole thing squared, and that comes out to a scale factor of 5 to 1 squared. So the ratio of the perimeters is equal to the scale factor, and the ratio of the areas is equal to the square of the scale factor. If you're a little lost on this one, that's okay. We can go over it again in class tomorrow. Let's look at the study tip. The ratios tell you that the perimeter of the drawing is 5 times the actual perimeter, and the area of the drawing is 5 squared, which equals 25 times the actual area. Your directions for this assignment are to complete the On Your Own problems 1 through 4 below. They're also on pages 300 to 302 of your textbook. Show your work and be prepared to share during our next class. Please remember, to earn credit for viewing this flipped lesson, you must complete your exit slip, come to our next class prepared with the journal pages or other work from the flipped lesson completed, and be prepared with any work that was assigned in the flipped lesson completed. Be prepared with any questions you have for the teacher, and always have a good attitude. We'll see you next time in class.